you to the next session of Embedded Software Testing Unit 3, Static Analysis, Code Reviews and Metrics. Today's class is about continuation of the static analysis and code reviews, and this is lecture 4. So before that, we will go through the previous session what we have studied about quickly. So stack analysis is one of the important static analysis aspect. So stack memory has to be allocated while building the embedded program, and it cannot be underestimated as well as it cannot overflow. So to measure that, we need to do an analysis. The measurements can be done in different ways. So we need to have a binary executable with a map file. So with the map file, we can do offline analysis of the memory in terms of stack. Again, it depends on the type of system that we are using. And stack overflow is one of the issues that we have in stack analysis. So stack overflow will lead to a corruption of data, a machine exception, and unpredictable program execution, a software exception likewise. So an unintended stack overflow may occur during execution of a program for different reasons. The reasons could be a hardware would have failed, such as memory, interface, or the processor, etc. A software development error, that means the programmer or the developer would have introduced a unbound memory or such errors in the program, so that will lead to a software development error. An unintended software behavior, that means software has some issue, suddenly it is behaving unintendedly. So that is one of the reasons. Memory corruption, memory is not written properly or content of the memory is corrupted. And there is a single event upset due to which stack overflow would have happened abruptly. So likewise we have different reasons for the stack overflow. This needs to be analyzed. So as per the ISA guidelines, stack overflow need to be taken care such a way that the analysis is performed to define whether or not it is necessary to perform continuous stack monitoring. That means it's part of the built-in program or not. If continuous monitoring of the stack is used, it should be performed in real time when the program is running with a specified task allocated for it, a tiny program or a tiny slice of time that can be used. And the monitoring mechanism should be part of the requirements. In the event that the monitor detects an overflow, the expected behavior should be specified and verified accordingly. So that's what the ISA guidelines talk about. The next one is the coding standards. This is one of the important aspects that many people will not do or will not follow. This should be done by the IVNV, the Independent Validation Verification Team, in order to check that the coding standards have been followed. So why the coding standard is important is that there are high chances that due to a misinterpretation or violation of the coding standards or rules, a program can have bugs. To avoid that, there are different guidelines and suggestions. So one of them have been highlighted here, and it is recommended to use C standards and tools such as MISRA C Checker and MISRA C 2004 rules. So there are different types of standards and guidelines that it recommends. It recommends in terms of the complexity of the program. A poor coding standard can be worse than no standard, so better to have a standard. The common objectives of the coding standard is reliability, portability, maintainability, testability, reusability. It should be extensible, and readability. That's very important, so that the code is maintainable. So sample rules. So we had seen, like we cannot have multiple statements in a single line. Readability is lost, and we cannot have a macros except the source control. Identifiers should have been provided with a descriptive or meaningful names, and the function lines cannot be more than 200 lines. is difficult to maintain, and the scope of the identifier should be very clear, such as declarations shall be declared in the smallest possible scope, and typecasts should be used only when it is required, not always. And the precedence, this is one of the important aspects of the programming. The precedence rules have to be well controlled, and increment and decrement operations should not be used within the sub expression. So these are some of the rules that we have seen in the earlier class. Today we will see about continuation of the static analysis and code reviews. Okay, so coding standards, coding rules, power of 10. This is one of the good guidelines given by Michael McDougall. He recommends 10 good rules. If you follow, definitely your program is matured and chances of bugs are very much avoided in terms of the trivial issues that could have been thrown in by the programmer or the coder. Okay, what are those? The power of 10. Let's try to understand. Restrict to simple control flow constructs. That means the control flow construct should be as simple as possible. Try to break a bigger complex programs into smaller constructs. That's what it means. The first rule is about do not use go to statements, set jump, long jump or recursion. So recommended to avoid these things. Second rule, these are called as golden rules by Michael McDougall. So second rule is about give all loops a fixed upper bound. Definitely we need to have for loops, but with a fixed bound where it is going to complete or where it is going to end. For example, we have a for loop I less than 0, I plus plus. We should not be completing here. It will never end. I should end with some 10 or 100, whatever it is, and better to avoid any expressions such as some constant value or something like that, constant expression. So this will definitely lead to a upper bound, and upper bound has to be used in the for loops or while loops. The next golden rule: do not use dynamic memory allocation after initialization. So we know initialization is very important. Any variables or objects that are to be defined should be initialized using the initialize function. Once we have initialized a variable or memory or any program flow constructs, we should not further work on the reinitialization of the memory, especially. That's what it talks about. So better avoid this kind of a allocation, that is how much memory is going to take during the program execution. You fix it in the initialization only and allocate accordingly. So do not use dynamic memory allocation. But dynamic memory allocation is a big chapter by itself in embedded software systems. Some people are for having dynamic memory allocations because they don't know the behavior of the program. So especially where they use a C++ code, there is a free, new and all that sort of a dynamic memory allocations available, but it is recommended to avoid that as much, and especially after initialization don't use, if at all using the dynamic memory allocation, don't use again. That's what it means. Okay, the next one, limit functions to no more than 60 lines of text. So we have seen 200 lines in the one of the guidelines, but Michael McDougall says 60 lines is a maintainable code, or a good enough number of lines for an embedded system function. Text here means an executable lines of code or executable object code. It's also called as lines of code. Lines of code could be having executable plus commands. What it means here is programs. So better avoid more than 60. Use minimally 2 assertions for every function of more than 10 lines. So if a function is having more than 10 lines, minimally 2 assertions have to be there. That means every function should have 2 assertive statements minimum if it is more than 10 lines. That's what it means. Sixth one, declare data objects at the smallest possible level of scope. That means if you have a innermost levels of the scope you are going to define within function, sub functions likewise, better to declare if it is required to be used in that level. So use that within that level of scope, any declaration of the data objects which is going to hold the data. Next one is check the return value of all non-void functions. You know void functions and non-void functions. Void functions will return nothing, it will return 0. Depends on the system again, it could be 0 and default value. Non-void functions will return any non-value. So check the return value of all non-void functions and check the validity of all function parameters. So this is a golden rule, very good, should be applicable for any standards. That means the parameters whatever we follow or we pass within the function, parameter 1, parameter 2. So like this we have a declaration, right? Parameter n is the declaration, and here we have a return. Suppose return is some int x could be a, better avoid, some signal suppose. So it will supposed to return a signal, and we need to check whether it's the right way it is getting done, the value that it is going to return, especially for where we have a return with some value that is nothing but non-void functions. And also we need to check the validity of all function parameters. That means parameter that we are going to pass and use within the function, better to check whether it is rightly defined and used. That's what it means. So next one is limit the use of preprocessor to file inclusion and simple macros. It means preprocessor lines are there, right? Like include and any macros, etc. So all this you avoid to use only for file inclusion. Includes, for example, we have stdio.h and any macro like as defined debug could be true. So simple macros like this and any inclusions, file inclusions, only use it. You limit it basically, not more than this. Actually, there are a number of pre-process like while loop, for loop, if, and all that. So try to avoid have simple macros. That's what he says. So it's better maintainability and chances of bugs are less by having a simpler macros. But complex programs may need, but better document it and use it as per the need with the control of the developer or the programmer. Next one is limit the use of pointers. So pointers is a very important aspect in the embedded systems, which points to a memory where it is getting referenced when it is getting used. So try to use as simple as pointers in terms of referencing it, and try to use arrays, variables, and all that. When it is absolutely necessary, use it. Use no more than one level of dereferencing per expression. That means we have a referencing and dereferencing for pointers. Better don't use more than one level for the dereferencing of the pointers. So limit it. The last one being compile with all warnings enabled in pedantic mode and use one or more modern static source code analyzers. That's what source code analyzers we have seen, we have studied, like in terms of understand for C++ or poly space or anything. So use that and try to analyze whether any warnings, any violations are there. And in addition, it's very important to have the compiler throwing warnings or info or errors getting fixed. That's very important. So we need to have the compiler giving the warnings. We cannot disable that option in the compiler because warnings could lead to a catastrophic error or catastrophic issue, because compiler won't care about that. Whatever the user has set, that it will going to do it. So better to take out all that warnings. That is what it pedantic mode means. Disable it and use one or more static analyzers to analyze any dead object, dead code is there, complexity of the program is how much, and all that will be taken care. So that is what is about the 10th rule. So this is what classic coding rules that needs to be followed. If this is followed appropriately, definitely the chances of program being having errors are very less. That's what based on Michael McDowell inputs is been taken care. Okay, so that is the end of coding rules and code reviews. Now we will come to the embedded software program reviews, inspection and process. This is very important part of the static analysis. Is one of the important topic for embedded software testing. So we need to have a right method of reviews, right inspection and process that is getting followed, so that during the review we will bring out all the anomalies of the program or any of the elements of the embedded software system. So very important to have reviews, inspection and process. So each development phase is a translation from previous phase. We know that phase to phase review, and how you move between phases. We will generate few work products, right? We have seen the entry and exit criteria. So each exit criteria will result in a work product. So we know that we have embedded systems developed in phases. Each phase will produce the outputs or any products or byproducts from the review. It could be any of the development phase, and it is purely based on the translation or the transition from entry to exit. So as a result of exit, as an evidence, we know that some product or byproduct is being done or delivered. So that is what it means. This transition needs to be tested. How we are going to test this transition is proper or not is called transition or phase transition. As a result of this, there are several artifacts that is going to come out that needs to be tested. Tested means those are something like a document or code or any of the analysis, anything it could be. So all this need to be tested. So test we will do with the help of review or inspection or walkthrough. There are different type of reviews. We will study that one by one. Okay. So we know that in an early stage of the development cycle, majority of all the defects, about 50% of all the defects comes from the requirements or the specification, function specification, and a review process should prevent the defect migration. That means the review process will prevent the defects at the earlier stage. The cost of defect migration to the next stage is much higher than finding defect in the phase where it was introduced. At the next stage, it can cost an order of magnitude more and an order of magnitude more again and again at the stage after that. So we know that every stage we pass on, so the cost will go high as we get more issues. So the cost is maximized if the error is detected after the product is shipped to the customer, and minimized if it is detected in the phase where it was introduced. So better to trivialize the defect when it is introduced or when it is injected as soon as it is done, and avoid or reduce as much when it is going to be shipped or when it is in the process of shipping to the customer. Okay. So we know there are different phases of the life cycle in the embedded software system. Just repeat, it could be a requirement specification, function specification, design specification, code, user's guide, that is the release, then test plan, test specifications. These are typical embedded software phases. So we know that requirement specification phase, the purpose of the requirement phase is to ensure that the user's needs are properly understood before translating them into the design. In the requirement specification, the purpose, scope, performance of the requirement deliverable are clearly defined. Acceptance testing is performed against the user requirements. So all these artifacts needs to be reviewed. The next one is the functional specification. The functional design is the process. Function specification or design is the process of translating user requirements into the set of interface specification or the function specification. The function specification, the scope, characteristics and performance criteria of the system in terms of hardware and software that meet the user requirements are clearly defined. So system testing is performed against function specification. So basically this requirement specification is user testing or the acceptance testing, function specification against which we will test at the system level, which is nothing but the system testing. So definitely there are products or byproducts of these specifications that needs to have a review or analysis. The next is the design specification. So the internal design is the process of translating the system requirements into the detailed set of data structures, data flows, algorithms, anything it could be. So in design specification, the most appropriate physical solution positioning against existing architecture and applications to meet the agreed system requirements are clearly specified. Component testing is performed against the internal design, that is architectural design or low level design is also called as, and the component testing is done with the help of the code. Also it will use the database with the help of low level design. So next is the code. Code is the process, coding is the process of translating the internal design or specification low level design into the specific set of code. So what we are going to check during the code is, are there any data reference errors, data declaration issues, computation issues, comparison issues, control flow errors, algorithms, calculations, control flows, then what else, interface errors, input output errors, data flow, data declaration, references, all these are part of the code, and check against that should be done when we do the review of the intended code. The next one is the user's guide. So basically every software product that is delivered to a customer consists of both the executable code and the user manual. So basically executable binary we are going to deliver, and how to install and how to use it. The embedded software code on the target board has to be instructed properly to the user of the system. It is nothing but the user manual. It is also called as user guide, or which will be having the work instructions how to use it. So this documentation is no less important than its code. So equally it is important like code, because its quality is a significant factor in the success or failure of the product. From the point of view of the user, if the manual says do something and the user follows these instructions, and if it doesn't work, it doesn't really help that the code is in fact right. That means there is some issue. It is not behaving what is documented. So that is what the usual document or the plan is required. Test plan, we know. So what are the aspects of the test plan? It has to have all the stakeholders and who is going to test, what is the schedule, what is the environment. All this will be part of the test plan, like tools, cost, and I mean the schedule, how long it's going to take, what sort of a level of testing is going to be done, with the help of what tools, likewise is going to have. Last one being the test specification or the test cases itself, how test cases are strategized, how it's going to be designed, all this will be there. So that needs to be reviewed or inspected using a process. That is what review has to do. So these are the things that has to be taken care during the review process across the life cycle of the project. So basically why it is required is each life cycle will produce some sort of a output. The output could be one of these requirements, functional specification, design, code, user guide, test plan, and test cases. Of course, we can have more like test reports, execution reports, failures, process, metrics, etc. So we will take each one when you go through the next session. Okay. The next one is how much we can review. So first one is what to review in the embedded system. The next one is how much out of this we need to review. Am I going to review all the 1000 requirements? Am I going to review all the 1000 artifacts that are supporting information for the requirements? Likewise, we are going to have. So we need to have a careful sampling. It is called as sampling basically. Suppose for example, there is a requirement specification, there is a function specification. We are going to sample using the sampling criteria, which will be defined during the plan of the testing or the development, which will say suppose 30% of the sampling should be done. That means if there are 1000 requirements, 300 requirements have to be sampled to see that whether it is in place appropriately within the assigned or identified module, whether the specification is as per the standard. Likewise, this is basically from independent perspective. Of course, a developer's perspective, whoever is going to develop has to do a 100% review. It's called as self review. So self review has to be 100%, and we have a peer review that also should be 100%. That means peer review means person A's products will be reviewed by person B and person B's products will be reviewed by person A. So both of them are peers. To have an independency, they need to cross check against each outputs or the byproducts. So all of this like design specification, code has to be reviewed, users guide has to be reviewed in terms of sampling at the different level. Of course, we have a quality team or the quality person who is going to review based on his criteria. It could be 10%, 20%. It is again depending on the criticality of the program. Program is nothing but the entire development life cycle or criticality of the level of the software, whether it is a more critical, less critical, medium, safety concerns are there, security needs to be taken care. All these factors in terms of the review selection and how much to review. So that is what is very important for doing the what to review and how to review aspects. Okay, coming to the review details, like we have different types of reviews and different types of program inspections and different types of walkthroughs. So what are those? Okay, and why it is important? Why? Because not all testers of software applications read the code, but the concept of studying program code as part of testing effort certainly is accepted, because it is going to be emphasized as a one phase of program inspection, walkthrough and reviews. Definitely we have to have a dedicated process for doing this. Then only the importance of the understanding the code and reviewing the code will going to exist. So several factors may affect the likelihood that a given testing and debugging effort will include people actually reading the program code, the size or complexity of the application, the size of the development team, the timeline of the application development, all this matters, and the background and the culture of the programming team and the testing team. All these are very important in identifying the review process, walkthroughs, inspections. All these are important factors. So basically, this is not a computerized or computer based testing. Of course, we use some tools in terms of identifying the reviews, walkthroughs and all that, but this is not automated generally. The reviews are not automated. Purely it is done by humans. It's called human testing, whatever you want to call it. So no automation is done. Here automation is not done means for reviews there is no tool in terms of producing the review aspects. But once we have the reviews, we can have the metrics and category of errors and all that using the Excel sheet or any tool like such as Bugzilla or whatever it is. So human testing it is basically called. And inspections and walkthroughs involve a team of people reading or visually inspecting a program. With either method, participants must conduct some preparatory work. Any method they can use it, but you should read or you should visually inspect. That is what inspection means. And walkthrough also same thing. The climax is a meeting of the minds at a participant conference. Then the objective of the meeting is to find errors but not find solutions to the errors. That is to test, not debug. The primary thing that walkthrough and inspection does is first they will go through the or they will inspect the program. It could be a requirement, it could be a code, or it could be an execution, anything as part of the artifact of the embedded system. So it is very important to have process in terms of inspections and walkthroughs, and basically at the end of that we are going to meet all the reviewers, whoever has done, all the inspectors, whoever has done, at a participation conference. The objective is to find the problem, that's all, and conclude whether the problem is rightly identified or wrong or not rightly done. But there is no solution that is going to be identified, just the reporting of the errors that is being inspected or that is being reviewed. That is what the aim of the next phase of the inspection or walkthrough. So there are different methods for doing this. That could be any analogy method such as any standards following or any programming process, or we can have some criteria keyed in the computer based testing. That means we can have a checklist identified in a tool or Excel sheet, and against checklist there will be a tick mark and non-tick mark. The user will key in and will generate the report. So that is about program inspections, walkthroughs and reviews. Let's study about program walkthrough. Okay. So basically this is referred from art of software testing. What he says is, in a walkthrough, a group of developers with 3 or 4 being an optimal number, it could be more depending on the complexity of the embedded system, they will perform the review. Only one of the participants is the author of the program. Okay. And the majority of the people other than the author. So one will have an author, the others will be supporting him in terms of doing the review. So they will do following the testing principle, stating that an individual is usually ineffective in testing his or her own program. So basically we do in a walkthrough, a group of developers, 3 or 4 depending on the complexity of the program. One will be the author, others will be the reviewers. So that's what is going to happen. So an inspection of or walkthrough is an improvement over the older desk checking. Usually developers used to check by self review, but this is an improvement that we have seen nowadays. Inspections and walkthroughs are more effective basically, again because people other than the program's author are involved. So definitely it is going to be effective. Independent and unbiased review aspects will be taken up. Another advantage of walkthrough resulting in lower debugging, that means error correction, anything we need to do, we don't have to spend much time, the cost will be less. And when there is an error found, it can be precisely located which part of the code this error is there. So that is the advantage of this inspection. In addition, this process frequently exposes a batch of errors or a group of issues, allowing the errors to be corrected in one shot. Whereas instead of inspection, if you do a computer based testing, normally it exposes only a symptom of the error. It will just throw the error, it will not identify where the problem is. So that is where the advantage of inspection is there. Okay. So inspection, continuing that, a program inspection is a set of procedures and error detection techniques for group code reading. Basically it will be read in a group. Most discussions of code inspections focus on the procedure, forms to be filled out and so on. It means there is a checklist and review guidelines as per the inspection guidelines. As per that, the inspection process will be taken care. Here, after a short summary of the general procedure, we will focus on the actual error detection technique. An inspection team usually consists of 4 people. One of the 4 people, this example is basically from a typical embedded software. Don't get biased or take this as a definite number. It could be 5, 6, depending on the complexity and the intended program. It could be less also. So one of the 4 people plays the role of moderator. The moderator is expected to be a competent programmer, but he or she is not the author of the program. Basically he coordinates, he is the moderator, and he need to be acquainted with the details of the program. He knows whom to contact, who is the stakeholder, all this information the moderator will have. So the duties of the moderator will include distributing materials for the people and scheduling the inspection and the inspection session, and he should lead the session. you should record all the errors that is found in the session, ensuring that the errors are subsequently corrected. That also he has to ensure, so that the errors that are going to be cleared or not will be communicated to the reviewers. Okay, tools: an error checklist for inspections, data reference, computation, data declaration, comparison, control flow. All this will be part of the checklist. Against that, the check of the program will be done. So basically, the moderator is like a quality control engineer. The second team member is the programmer. The remaining team members usually are the programs designers, or he can be a different programmer. And a test specialist also can be involved. The moderator distributes the program's listing and design specification to the other participants well in advance before the meeting, before the inspection session. The participants are expected to familiarize themselves with the material prior to the session. During the session, basically couple of activities will occur. The programmer narrates statement by statement the logic of the program. So during the discourse, other participants should raise questions, and they should be pursued to determine whether errors exist or not. It is likely that the programmer, rather than the other team members, will find many of the errors found during the narration. That means they will raise the hand and raise the issues. The simple act of reading aloud a program to an audience seemed to be a remarkably effective error detection technique. That's what one of the activity. The second activity is the program is analyzed with respect to a checklist of historically common programming errors. So two things will happen. One is narration, other one is analysis. So narration, he will narrate the code, logic and all that. So user will raise the doubts and it will be recorded. In the second one, analysis will be done against the checklist, such as whatever is listed here. The whether program has any errors in terms of data reference, computation, etc. So all this will be recorded in the inspection, and as a result of the inspection, he will distribute the errors to the developer or the author of the program, and the moderator has to ensure that those errors are getting fixed or justified, or it is rejected or accepted by the implementer. That is what he has to ensure. Okay, that is what is program inspection. So next one is the peer reviews. Yes. The peer reviews. This is also one of the important embedded system static analysis review method. So what are we going to do in the peer review? And we will also study about peer review and the types of peer reviews. So peer reviews, review method wherein is the review method wherein the other equal programmers or testers involved for evaluation. As I said earlier, testers or programmers independently review each other artifacts. That's what peer review is about. So there is again a checklist and guidelines same as that are used in the other review methods. Peers remain at same level as others. That's why they are called as peers. That means there are some 10 functions and 10 functions are getting developed by 10 people. And for these 10 functions, suppose another 2 people are developing the test cases or test functions. All are considered as peers and they can review across their artifacts. So they are called as peers. Any improvement on the updates can also be thought of. That means it is not just enough to do the peer review, identifying the bugs or identifying the errors that the program or the test has, but it is also important to have an improvement in terms of optimizing, automating, and speed. I would say improvement in terms of effectively effectiveness in terms of the output or the program, how much it can be effectively done. There could be a tedious method, there could be a short method. All this can be thought of. So that is what improvement can be expected in the peer reviews. So gives an insight into the approach and methods at a higher level while one becomes peer reviewer. It means it gives a holistic approach of what is being intended underneath the peer reviewed artifact. So that is what it means. So peer review is a very important aspect. So we will see the peer review process. What are the peer review process and types of peer review process? So there are three types of peer reviews that can be done: offline peer review, walkthrough peer review, inspection peer review. What are those? Okay, offline peer review process is as per below. The objective is, the purpose of the offline review is to evaluate the deliverable work product to verify its completeness, compliance, and find defects. The objective is to remove defects from work products early and to minimize the rework. That is what the offline peer review, where peer reviewers will not do together, but they will take offhand, and they will come up with the reviews. That is what the objective. Scope is offline review to be conducted for the following work products: basically project receivables, statement of work, contracts, whatever it could be. And that is what the offline peer review the follow. This is one example that what we have put. And internal deliverables such as PMP, project management plan, basically. So these are also can be offline reviewed. And as a result of offline review process, we have external deliverables like low level design code. It could be different artifacts such as SRS, function specification, design documents such as LLD, HLD, test cases, test plans, test concepts, test scripts, test results, selected service system components which are identified in the transition plan. All these are part of the offline review process. Okay, let us see the next ones of the offline peer review, such as entry criteria, how we are going to enter into the offline peer review. We took an example as project management, how it's going to be offline peer review. So review planning in PMP is available. Work product ready for review as per the criteria identified in PMP. Inputs: product or process work item ready for review. Outputs: updated work products after review. That means review is considered as complete only when the reviewed are taken done and verified. Updated offline review defect log. The defect log will identify the reviews, and against each defect log there is a status such as open, close, in progress. Defect log will have a status, or it could be rejected also. So you should show one of the status, the defect log. Finally, to make sure that the review record is closed with all the individual defects are closed. So when it is open, that means the defects have been identified, and if it is in progress, means the status of the particular review is review artifact is in progress, that is under fix, is not fixed yet. Rejected means that defect identified is not accepted, it is rejected basically. So the exit criteria of the offline peer review process is reviewed and updated work products. All defects are tracked to closure and required sign-offs are done by the stakeholders. Capture all efforts of the review process. That means how much effort it has taken in terms of review process offline is getting captured. Next one is the walkthrough peer review process. We are going to have a walkthrough of the artifacts. Here the process objective is the purpose of the peer review walkthrough is to evaluate the deliverable work product to ensure completeness, compliance and find defects. The objective is to remove defects and work products early and to minimize the rework. Scope is offline review to be conducted for the following work products, basically statement of work, contract documents, anything is an example, and internal deliverables such as project management plan, external deliverables such as requirements, hardware requirements, functional requirements, board level requirements, design documents, HLD, LLD, test cases, test plans, etc. And walkthrough peer review process, entry, inputs, outputs, exit criteria, it is same whatever we have seen in the offline review process. Here the artifacts are walked through with different team members or the peer reviewers, and it is similar to the inspection. And inspection peer review process, what we do, the purpose here is to walk through and evaluate the deliverable work product to ensure completeness, compliance and find defects. The objective is to remove defects from work products and minimize the rework. Scope is peer review inspection that should be conducted on the work products such as project management plans, SRS, high level design, system requirements, service system design, any of the work products of the embedded system. This is an example taken from one of the embedded system process that is followed in the industry. All external deliverables and the documents, components which are critical in software development lifecycle should be subjected to the peer review inspection. It means all the external deliverables should be inspection peer reviewed. That's what the meaning of. The project manager or the quality analyst can call for a peer review inspection meeting in other circumstances also wherever it is necessary. Here also we have entry criteria, inputs, outputs, exit criteria that has to be mentioned in the inspection peer review process. Okay, so that is the end of the review process. And that is static analysis aspects in terms of the peer review and the static analysis, sorry, coding standards, what we have followed through in the last and today's slide. The next type of static analysis is the test matrix. How are we going to produce the test matrix? And what are the test matrix that are used for embedded software testing, and how it is going to be used in terms of static analysis? That is what the test matrix will bring it out. Okay. Quantification. So basically test matrix will bring, or it will quantify the various artifacts in terms of how much and what is the percentage, what are the pass fails, so what are not applicable, what is the burn down charts. Likewise, we have several metrics. Basically, the test metrics are getting quantified. Physics needs measurements of for time, mass, etc. Thermodynamics needs measurement of temperature. The size of the software is not obvious. We need an objective measure of the software size. It is not the metrics that is based on the size, but it is objective measurement. Basically, that is what is called as the quantification. This is very important when we do the metrics accumulation. That means when we collect the metrics, we need to be definite about how we are going to collect the metrics. Metrics is not just the size. How we can get it directly with the help of the tool. How much size, how much lines of code is there. Likewise, so better we do a objective measurement of the software. That is very important. Okay, quantification based on structural metrics. It is not the lines of code, as I said. It is structural metrics. So that is what test metrics will bring it out. Attention is focused on control flow and data flow complexity. We have seen that control flow and data flow, the worst case execution or the control flow plot and the objectives, its usage, all this will be part of the metrics we are going to cover. Structural metrics are based on the properties of flow graph models of programs. So that is what basically the structural metrics is talk about. So software quantification we do not on the lines of code. It is basically we need a notion of the size when comparing two testing strategies. When we do a testing, how we are going to test it. So basically not based on these lines of code. It's based on the complexity and the structure of the code. So something like we may come up with a strategy such as strategy A, strategy X needs some 2 tests per unit. Unit could be a piece of software. So likewise, we need to have a quantification. So basically, we need to be having questions before we develop the matrix in terms of quantification, how we can test it or what is the strategy and when we can stop the test, and how much we can find the bugs. It is something like percentage or it could be some number. Say suppose we have 1000 lines of code and we as a tester based on the design requirements and all, he'll work out a strategy and he is expected to bring something, say 10% of the lines of code suppose, or maybe 2%. 10% is too much. So 2% is something like 20 lines of the code is having an issue. So something like how many bugs we can expect from the piece of software when it is tested. So there is one of the test metrics. So which testing technique is more effective? Are we testing hardly or smartly? Do we have a strong program or a weak test suite? So these kind of questions we should have for collecting the various metrics while doing the tests. So it's difficult to answer some of the questions satisfactorily, but we need to have a matrix in progress so that we can discuss the aim of getting empirical loss in terms of size, number of bugs, number of test strategies, number of expected number of tests required to find a bug, testing techniques, its effectiveness. All this will be done with the test matrix. It's basically weightage. So that's what we do when we do the test matrix. It's basically weightage, structural matrix, quantification is all we have to take care when we do the test matrix. So it is not we are going by the size of the software when we capture the test matrix. It is going by the test strategy, the structural aspects of the software. The structural aspects could be control flow, data flow, and the complexity of the program likewise. So importance of test matrix. Why we need test matrix? Matrix is used to improve the quality and productivity of products and services, thus achieving. Basically, test matrix, with the help of test matrix, we know how much we have improved over a period of the embedded software lifecycle or over a period of regression tests or different types of tests, how much bugs we are able to gather, how much bugs we are going to fix, what is the maturity of the products. All these artifacts will be come up. Without the matrix, we cannot satisfy the maturity of the product. So definitely, we are going to report to the customer, and we can have a customer satisfaction based on this matrix. And it's easier to manage or easy for management to digest one number and drill down if it is required. If there is a critical issues and how those critical issues are getting done is all based on the test matrix. Different metrics trend act as monitor when the process is going out of control. That means when we do the testing, we are going to come up with a different matrix, and the trend of that matrix will definitely give whether the program is going out of control or within the control. We will study about this different metrics trend and all that. There are different charts in the future sessions. Metrics basically provide improvement for current process. That means when we follow the process, it is going to continuously improve. That is what the metrics is going to help. So basically, any process you take, such as CMMI level 5 or any level 6 sigma, etc., they basically look for the improvement and minimization of the errors when we do a production, when we do a process followed up, when we are going to have the life cycle implemented. So that is where the importance of test matrix is going to come up. Okay, so we understand that the importance of test matrix, how we are going to represent, how we are going to present it. So we will study that aspects in the next class. Objective of the test matrix and test matrix, how is going to be depicted, what is the burn down aspects of the test matrix, how the trends are getting set, etc. in the next session.